This video, we're going to record security onion exercise. We're going to cover the document security onion here on week 15. You click the Word document, download it, and also download the rule. For simplicity's sake, I already copied this rule into the security onion image. Once you open the Word document, we have to turn on at least about 5 systems for this exercise. On the outside, we're going to turn on Kali to perform the Metasploit attack that we have done before to the Meta-E, and use the security onion IDS to monitor and do a log analysis. And we're going to open 2019 as a tester. And the 2016 will use it as a slammer to grab the packet and ping the internal host at the translated address of 10.10.10.2. So in this exercise, all of those tester attackers and Kali, we are going to have to access the internal host at 10.10.10.2. We don't have to turn on power on the internet firewall unless we want to do a real rule update. The rule update should be recent. I created this image in May of 2020. So the information, the rule set in the security onion is still relatively new. Of course, we can power on the internet and run the rule update. The objectives of this exercise, we are going to deploy this security onion, which is an IDS security monitoring and log management solution using Snort or Suricata. Those are very similar IDS applications. And we're going to also introduce a newer concept for this semester, the Squeal, which is the analysis console for the NSM, network security monitoring. And we're going to analyze and look at the vulnerability assessment results, which been performed by the Kali, Metasploit, SQL Slammer, and also we just simply do some ICMP test to see how it logged and logged the packets. And this is what we have been doing using a different IDS, IPS, and different platform throughout the semester. So this is kind of like a review and also an introduce for a new NSM. Also, during this exercise, we're going to do something new by doing a replay that it comes with security onion. So you can actually see some existing or old attack that's been already put into the operating system security onion, and you can actually generate the attack again, and you can see which rule been triggered and look at the report of the NSM. And last one, what we're going to discuss is to compare in the VM environment and the non-VM deployment. What's the differences? And also we will compare with the Linux, Snort, Suricata, and the Cisco IPS. Pay attention though. When we do all the VMs, it's like a hub inside that everything can hear each other from this virtual switch. This virtual switch, unless we configure in such a way that it's becoming a real switch, otherwise it's function like a hub. If we use the default setting of the VMware Workstation Pro. So that's why the monitoring system can actually hear everything on the inside. And usually for any security appliances, we will have a management interface that's connected to the outside. and also a monitoring NIC that's connected to the network we want to monitor. And this one wouldn't have any IP addresses. It's silent monitoring for the internal network. If we wanted to do, a real hardware deployment, or if we configure this as switch, then we have to use the tab or configure the span, SPAN, for the switch port, so that you can hear the traffic coming in. If it's for the real network, then you have to put a tab wire before the network and for it to go through the security onion, and then so you can actually intercept with all the conversation going into the network. If you deploy with the one that we have here, then you don't have to do anything. Once you install it, it will work. It will start monitoring the system. Now the lab procedure, as we will download that, this is security onion version, and then we'll have 2 to 4 processors. This is the minimum requirement or optimum as far as the computer in the classroom goes. Of course, the more the better, but we have actually at least have to power on 5 boxes. So each one got about at least 2 gig, and this one was 4 gig. Then you will have at least about 15, 16 gig already been used by the virtual machine. So decision is yours. When you set up, you should do that, make that decision, and you can change it. And then there's 2 NIC. One is for management. We usually use the VMNet 8, which is the outside. And then the monitoring is VMNet 2 by default. That is actually a host-only network for the internal. And we can sudo reboot after the setup. And of course, in the exercise, I will do a sudo su so that we don't have to keep typing the sudo command. Again, after you install it, we can log on and then open the terminal. And here are some of those basic configuration. If you want to make the desktop look bigger and more readable, then you can actually open the terminal and then click the profile preferences, and then you can actually select different fonts to take a look at it. And we will stop the discussion now and started to do the hands-on and then come back and forth between the virtual machine and this document. You have to log into the VMware MSAC, and as the topology specify, we need to power on pfSense.net, which connect the inside and outside. And Security Onion has 2 interfaces. It connected outside management to the same network as the pfSense. And then inside is connected to the 10.0.1 network, but it doesn't have an IP address. It's just silently monitoring the network. And outside network, which is on 10.10.10, Kali, Windows 16, and 2019 test 2. And Meta-E, the internal server. So let's take a look at Security Onion first. And the username is Jim. Password is ChangeMe. You're going to right click on the desktop and then open the terminal. Then you will highlight and right click on your terminal space and look at profile. I will create one, and there's a profile preferences, and I choose the 16 font, and you can of course do different settings if you want. That's when you install it yourself. For the exercise at school, this is perfectly fine. We'll sudo to super user and CHANGEME so that you get the root privilege. So we can save some typing on that. It's the convenience versus the security. And in this context, I would just prefer more convenient over the security concern here. Now, we have NSM sensor restart as the document has mentioned, you can actually restart all the services, but if everything works fine, there's no reason for us to restart all the services here. So we're going to see SO security onion status, okay, and then use the pipe more or less to see the result. So we're going to do that, and in here we're going to say SO STAT. So you will see that the status is OK. That's important. And you will see your interface information here. And then we can type in Q, quit, to quit it out. Okay. So once we make sure that service is running, we can use the NSM squirrel to monitor the activities. And username, it will be Jim, and password is changeman. So if it's running a little bit slow, I just turn off the Windows 2019 because 2019 is only testing at the end. So we don't need to power on that many boxes. Okay, so then you're going to select all of them to monitor all the interfaces and operating system too. So this is the default settings, and there's a real-time event already been recorded, and you can see that they show packet data here and they show the rule here. So if you want to see the packet data and the rule, we can check that. And meanwhile, you can also do make it bigger. And then here, you can actually drag it lower a little bit so you can read your data rule better. And you can also, according to the document, to look at the agent status. It's always nice to check the status, make sure it's up and running before we continue on. Now we'll try to do a ping and then see if we got anything recorded in here. So we are going to go to the Linux here, which is the Kali. And we are going to log on and then open the terminal from the Kali. And we can ping the translated address of the meta-e server 10.10.10.2. And we don't want to ping them many times. They just ping it for 3 times or 5 times, depends on how you want to do it. So you will see that the 3 successful ping has come back. And now let's take a look at Security Onion, the recording on that. And you will see that, okay, you have, if you highlight it in here, this is the new recording here. It's from Kali at 10.10.10.44, the Linux box, ping 10.0.1.2, and it's ICMP GPL info. And you can see we have which rule, where is the rule location, and the data that's been showing here. So it's very convenient. It's more very powerful too. And instead of giving you 3 lines as a generic installation of the snort, you may see 3 ICMP, and actually it organizes it for you. Say, hey, it repeat the 3 counts in here. Okay. Now we're going to do 2016 to do the same thing. So we're going to ping 10.10.10.2. And of course it will work. And let's take a look at the security onion. And it doesn't actually see anything. If you want to, it's actually real time. But if you want to refresh it, you can go somewhere else and come back and you didn't see anything locked in there. So this is what the document. We are currently on page 3. So once you use Linux, it recorded. But when you do the Windows 2016, it wouldn't lock. So now what we're going to do is we are going to run the packet builders to run the Slammer attack to try to generate the traffic, go through that. So we will do that. So we can do LP-A. So you will see that the 10.10.10.2 is the 3A here, and the 53 is, which is the same. So these two are actually the PF senses outside. So we have, when we wanted to generate Slammer and send it to 10.10.10.2, we have to use this as the MAC address in our packet. Otherwise, it will send it to its default gateway, which is not the PF sense. Okay, so we have to. This is like a review that we have done before. So we're going to mark, and we're going to mark the MAC address. Copy, and we'll run the notepad, and we paste it in. We're going to replace the dash. We have done this before with the colon, and replace it all. So, and then we'll make a copy. So we get the MAC address of our Colosoft first, get it ready. And this is the Colosoft packet builder already been installed, just like before. And we're going to open import the Slammer packet, which has already been done in here. We have done before. And now here, very important thing is the destination MAC address. It has to be oops, let me just make sure. Copy. And we paste that in. Okay, so make sure that it's the 3A at the end. If you say I move it, you will have the same MAC address as my demo here. And the source address, well, we're going to leave it the same, except it's Windows 2016. I just wanted to put it so we know. It's this one. And the IP address, very important thing is we can leave this alone, or we can change it to something else. 221 is fine. But we have to change the destination to 10.10.10.2. Otherwise, it wouldn't pass it over, right? So once this is done, now let's generate it. You can click on the checksum, click on the packet under here, and then you're ready to send. And we can loop it, and we can send it, say, hey, let's send it 3 times, and then stop. 1, 2, 3, and then we can actually go to our security onion. And you can see, sure enough, this is SQL Slammer 1. It's already been built in here. And it recorded the 3 packets coming in, and then you have seen all the detail in here, and you can see which rule got triggered and the detail packet in here. So you can actually look at the detail of the source IP, destination IP, and you have all the information at your fingertip, pretty much to do that, have a better picture of what's going on with your network. Now this completes our Slammer attack exercise. Now let's go in and do the Kali to take over the Meta E box that we have done before. So we have to click here and /etc ini.d, and let's start a SQL server for it. So we first started SQL services, and then we're going to click on the Hermitage here. So click it just once, it should be enough. Don't click it more than one time. Then you will have multiple instances running. And you're going to say connect, and yes. So then your Kali will be, your Hermitage will be running. And the Metasploit, what we're going to do is we're going to first scan and then find the attack, and then launch the attack. The document here actually briefly tell you what we do in here, and you can refer to the document for how to do that. First, we click here on the desktop here, right click, well, click on host and add a host, and 10.10.10.2, so we can add a host in there. So the host will be added, and we will right click, and we can actually scan it. And you just make sure that it's finishing all the scans. Usually it takes about 20 seconds or 30 seconds. Okay, this one takes a little bit longer than I expected. See that the scan complete in 79 seconds. So it's 1.5 minutes almost. When the network is not as busy, I have seen that it finished in 20 some seconds. So make sure you see the scan complete. Otherwise, your exercise won't be as expected. Now, once you do that, you click on here, and under attack, you can find the attack. And this part should be going pretty quick. And after that, you can actually right-click and attack. We're going to do the same FTP attack and the backdoor that we have done before. So we're going to do that. And lhost is the Kali, and the target is remote. So that's nothing new. So let's go ahead and launch it. Okay, so the attack is successful as we expected. And now if you come here, you will take a look at it, you will see that Kali. And if we click this one, you will see that, hey, it also have the time that's recorded of what's going on. And you can see there are some of those. You can see some of those ET emergent threat scan to come in through SQL port. That's the scanning port here. And then you can also see eventually our Linux box actually returns the root privilege to the attacker. So that actually tell you that it's critical that you have to investigate that. So that completes our pretty much test number one, which is pretty much a review of performing the exploit that we have done before, and using this security onion to double check on what kind of network NSM it will bring us a new perspective to do the log analysis more effectively. The second test is we are going to locate some of the existing samples and do a TCP replay, and you will see what kind of results and what kind of attack and what kind of logging that you can double check on that, and we're going to perform that. So we can reduce it, and then we're going to locate it. So we can type in locate. And you can see that there's a location for the sample files. Then you will have to type it in. So once you locate the sample file, take a look at your interface. It's actually ENS34, you can tell. And another way you can actually look at it is actually issue an ipconfig pipe more or less. And you can see that ENS33 is the outside interface of the security onion, and ENS34 is our monitoring board in there. And we can quit. So just follow the document. Now you know why we need to enter the interface for ENS34 to do the replay, because that's our monitoring interface. So once you do that, you will see that we completed the replay on that. And let's take a look at this. And you will see at the end, you can see there is a file download happened with some of those attacks from the internet. So that's from the replay of the bot, the Trojan. So that's our second test using some samples that come with the security onion for you to observe the emerging threats in here. So this screenshot is one that is going to be generated just like your machine here. Now we're going to do the third test, is to add a custom rule. That's what we've been doing before. We're going to add a window rule into it and a Slammer rule. And if you want to download it, then you will use the, you will have to turn on the internet and to save some resources. I didn't actually, I pre-downloaded it. Otherwise, you will have to turn on the power on the internet firewall, and you will, from your security onion, you will sign on to your Canvas account and download the file. The file has been downloaded to your home folder, and then under the download folder here, so my local rules. So we can do an ls, and you can see we have a download, right? And you'll be able to see my local rules. So let's demo my local rules just to take a look at what's in the rule here. If we need to update it, we'll update that to make it look like the one in the document here. The one in the document tells you that the first one we want is to make sure it says it's MySQL, which is the Slammer rule. And we're going to focus on the second rule and the third rule. We're going to make it more clear. There's a Windows echo request, and its echo request type is 8. And echo response is code type is 0. So we tell there's an echo reply, and we'll make sure it says window echo request. Echo reply including the Linux as well. So those are the two. And you can see that the signature is ABCDEF and then loop it back. So that's the Windows echo request. All right. So make sure it says Windows echo request, and then you can do a down arrow key here, and make sure this type is actually 0, and it's ICMP echo reply. So you will hit Control O and then hit Enter, and then we can exit. Close the terminal. Get out. Okay, so it's done. So if the window got terminal got closed, we can open another one. And now we are going to follow the document to actually copy the file into the local rule into the Security Onion Snort's local rule. And we first have to chmod to make sure, like what we had done before. We're going to chmod 777. The location of the rule is etc is in the etc NSM under rules, local rule. And so we are going to copy it over. We can, of course, try to see it. We can cd to etc, and then, well, there's a lot of things in there. So you can actually cd to rules, oops, NSM, cd to NSM, network security monitor, and ls. And you can see this is the security monitoring folders in there with a lot of information in the set, and rules is one of them. We want to go in, so we can cd to rules. Ls, see, oh, okay. So if you do ls-al, list the detail, you will see that most of them is just rewrite, and we are going to make sure that it's executable and all that. So we're going to do chmod. So we are going to do chmod 777 dot is the current directory, and local rules, we're going to change that. So then we can again do an ls-al again, and you will see, okay, the local rule now, we change it to 777. Now we're going to just echo my local rule into the local rule. And you can see it's nothing in here, it's a 0. So according to the document here, what you're going to do is you're going to cat my local rules into the etc NSM rules or local rules. So the location of the download is under, of course, under the root home gem downloads. And so you can actually cat, we can type it all out. So we can just cat the current directory, my local rules, which we already including the signature that we want for the Windows, and echo request and echo reply, and put it in there. And if we wanted to take a look at that, you can /al, and we'll go to etc, and that's in NSM, and rules. I think it's called local rules, right? So you can see that it has 508 bytes in there already. Okay. Now we're ready to run the test again. So we're going to go from ping from 2019. Let's do 2016 first to ping it. We're going to exit it out of the computer. And we'll go to the command prompt. So this time we're going to ping 10.10.10.2 now. So we go to Security Onion, and let's take a look at the squirrel. So after we ping, it didn't actually log anything. Nothing got changed. That's because we have to the rule is not dynamic. Once you update it, you have to run the rule update. So it will merge the local rule into the downloaded rules. And then once we do the rule update, then the Snort or Suricata, depends on which one you deployed, it will have the new set of the local rule, and then the ICMP will kick in. So let's do that. So let's run the rule update. So after we did the rule update, then we go to the Windows 2016 and we issue another ping to the 10.10.10.2. And now we go back to the security onion. And you can see that you have from 10.10.10.16, which is the window box. Now you ICMP ping window echo request, and then ICMP ping echo reply back. So you will see that this is the one that we edited. You see ICO 0, and this one is ICO 8, type 8 in here. So you can see that 4 packets from these boxes. Now we're going to continue on with our test. Okay, so we go to Windows 2019, and we're going to have to start up the guest. And while it's starting, we can go from Kali, and we can go ahead and ping it. Well, let's ping it 3 more times. And then, well, let's go to 16 and let's do it 1 more time. So we look at the security onion, you will see that, oh, okay, now it has increased. You can see that we actually used 2016 to ping it twice. And so it's recorded 8 of the echo requests. And then with the Kali, 3 of the echo replied has been added to it. And you say, hey, where is the other echo request, which is triggered in here is the GPL ping. It becomes 6 instead of 3 now from the Kali. So that's everything has been organized for you to see that. So you will see 8 of the echo requests and 11 of the reply. Another 3 GPL has been logged to the other side, the other event. Now let's see if the Windows 2019 is up. So we go to the command prompt and let's ping 10.10.10.2. And let's go here to take a look at it. You say, oh, okay, now we got additional echo request now. And let's just refresh it back. So you will see that so you'll see that the new source here. So it did log it as a separate entry here. You got 4 of the echo request. And the response, then it just summarizes it all into the detail here. And if you want to look at the detail, you can click on the 15 here. The mouse has to be right on top of the 15 here, and then right click, and you can view the command events. If you highlight some places and right click it, it will be different options. So it's somehow a little bit tricky. So you click that and you view correlated event, and you will see all these packets that has been logged it for different hosts, 2016 and then 2000 and then Kali and then 2019. Now they have echo reply. load it and record it from the interface here. And you can see the location, which line has been triggered. So that's under your local rules, line 3 in here. So this is the where the snort rule got triggered and locked. So that completes this exercise, and let's discuss and conclude the exercise here. We have repeated the same ICMP, Slammer, Kali, Metasploit through the monitor of the new sensor. So you can compare the differences between the previous exercise with the Security Onion. Security Onion also have a commercial product that you can purchase from them, just like pfSense. And we also introduced the Squeal, the NSM console for you to get better analyze of the data. And the outside important thing is the outside interface of the Security Onion is actually the management. So we can SSH, or you run the VNC from the other boxes to manage it. In our topology, we put it into 10-10-10, which in the lab is okay, but in the production network, it's not good because you don't want to put management interface out on the internet or even in the user network. It should be a separate management. That's why it's called management. Management network only allows IT manager or whoever security officer, they have access to it. So if your internal network is 10.01, your outside is 10.10.10, then you should probably create a 10.10.9 or 192.168.1.0 network for the management and use a separate virtual switch or use a separate switch for your workstation for the IT manager or security officer be able to connect to the management network and manage the box. The inside network, of course, is set to listen only. So therefore, it is a requirement for all of the IDS and IPS the same way that you're going to receive. You're not going to transmit into it. You usually will use a different management interface to do that. And again, for the physical network case, then we might want to put a network tab in order to hear the traffic. Or if you have a switch, then you have to spend a port in order to listen and record the alert log. That completes our discussion and the exercise.